from Altus. Altus is a company registered in Stuttgart, Germany, and we are based here. And our partners in this particular webinar session is ANSIT Consulting. ANSIT is based in India, and they are premier in providing the trainings and implementation services, especially in the engineering and IT services. So we will come back to them. I would like to give a very brief overview on what Altus is, and then I'll hand it over to Karthik for the session. Karthik, can just go more? Yeah, thanks. So as I mentioned, Altus is an IT services and consulting solutions organization based in Stuttgart, Germany. And we are currently providing many such services for the industries and customers here in German market. You can reach us anytime, based on whatever that you will hear in the next minute, using our email ID, which is info@altus-tech.com or trainings@altus-tech.com. You can also reach us on the given mobile number on WhatsApp or direct call. You can visit our website altus-tech.com anytime to see what we are capable of and how we can help you out. Karthik, next slide, please. So what Altus does today is we provide services in 4 major categorizations. One is digital transformation. We help the small and medium industries in transforming their digital journey, starting from process change to end-to-end eventual hand-holding of implementations. Second set of block, what we deliver is training services. For trainings, we are partnered with ANSIT. ANSIT is pioneer in providing these trainings and also services from India. And we train our candidates and students in the emerging and most demanding technologies such as AUTOSAR, VR, AR, XR kind of technologies. We also do the legacy trainings such as quality assurance, automotive domain specific trainings. Third element is we provide quality assurance services, which means the testing services for customers here in Germany and European market. The fourth important element of our services is the consulting or staff augmentation services. We help our customers in finding the right talent in German market for all the needs such as engineering services or quality assurance or in the embedded technologies. So that's our fourth pillar. Primarily for this training, whatever that we provide, and I'm sure most of the candidates who are attending this training would also look for opportunities in future. We can help you with multiple organizations connects what we have got in the German market and European market across. So that's what we are. And with that note, I would hand it over to Karthik for this particular specific webinar. And anytime in future, based on this webinar, you guys can contact us and we can provide the additional set of trainings along with our partners. Thank you. Karthik, over to you.
Thank you, Altus team. So quick background about ANSIT. ANSIT is a 14-year-old company, and we've been in the market and we've been working exclusively on the automotive domain for the past 14 years. So we build tools for our customers like Bosch, Benz, some of our customers. With product development, we do product development in automotive services. We do consulting and training, all in automotive services. And when I say automotive, we work in the entire V cycle. We work in the verification and validation, and we also work in the product development. We also help these companies build their tool chains. So myself, I'm Karthik. I have around 16 plus years of research, primarily in areas of automotive and RF system design. That's where we come from. So let's just get into the webinar. So today our webinar will be on AUTOSAR. So today it is one of the most sought after buzzwords in the whole automotive industry, and every car domain or car manufacturer is moving towards the AUTOSAR standard. So today what we will be talking about is we'll talk about why AUTOSAR it's necessary and what is the scope as in, because one of the things the Altus team wanted to touch upon is what is the scope for an individual in AUTOSAR. So that is something that I also wanted to touch upon. And the second part is where we will focus on what is AUTOSAR actually. The third is we will talk about AUTOSAR architecture. So like say we will compare and contrast with the existing architecture, the existing legacy architecture, and we'll compare it with AUTOSAR architecture and how it is robust and how it is done. And we will also touch base upon methodology. Like say my objective is to help you understand what kind of tools are being used in AUTOSAR. As an engineer, if you decide to take a career in AUTOSAR, then I also wanted you to kind of introduce you to what are the objectives, what are the career paths that are available, and also like say what are the tool chains that are available, both from a development perspective and from a career perspective. This is where our theme will be focused on. And like we mentioned, it will be like 55 minutes to 60 minutes. So we will, it will be a 60-minute webinar. All right. So at the end of this training, what we will be helping you will help you understand the entire architecture of AUTOSAR. That's something that we will assure you. Then we'll also help you understand what kind of tools are being used in the AUTOSAR architecture. Third, we will also talk you how what are the what kind of a documents are required. Like say, where do you start? What kind of a documents do you need to read? So these three things we will be able to cover in this webinar. So these will be the three prime takeaways for you as an outcome of the webinar. All right, so let's start with the first topic, why we need AUTOSAR. So let's assume today the whole concept of how development happens in the legacy methodology. So legacy methodology is where when I'm talking about automotive, all those things, I'm talking about one thing. We are talking about how do we build our electronic control units. All right. So basically an electronic, a car today has around a typical car like Benz will have somewhere around 80 to 100 electronic control units. A small segment car, a passenger car in the smaller segment will have around 20 to 25 electronic control units. Everything like say from your power steering to power windows to power brakes to your gear systems to your interior lighting system, everything is like say managed by your electronic control unit. So what is an electronic control unit? If you look at it detailedly, electronic control unit is more of an embedded architecture, right? So you have a hardware underlying, and you will like say it's pretty much a microcontroller, right? It's a pretty much a microcontroller with more details, right? So an electronic control unit is nothing but a microcontroller with a CAN bus, which is used for networking. It will have like say different IO protocols, like say SPI interfaces and all those things. And there are quite a lot of peripherals. So it's primarily what we call it as a microcontroller architecture, extended electronic control unit, right? So when I'm talking about an electronic control unit and I say it is a microcontroller based architecture, I'm sure all of you are aware, all these embedded architecture are hardware dependent. Like say when I'm writing the application software component, let us say for example, I want to control one input output device. Let's say for example, the smallest example that I can talk about is, let's say for example, when you open the door of your car, your light, your interior light is turned on, correct? So the electronic control unit which manages this is there will be an IO unit, and the IO unit will be connected to the light, correct? So when you write this application software, how you write the application software component is you will say that when you open the door, you will write kind of read this information, and based on this information, you trigger the IO, and the IO will go on and switch on the light. So the whole idea of today, what we have is the whole code is based on the underlying hardware. So tomorrow, if you change the microcontroller, or in a right word, if I have to use the automotive word today, if tomorrow, if you change this electronic control unit, say for example, your semiconductor device today, you buy an electronic control unit from NXP. Let's assume you buy the electronic control unit from NXP, and tomorrow, let us say, for example, for some reason you want to move from this architecture to another architecture. Maybe like say today you are working on a single core processor. tomorrow you want to move to a multi-core processor because you want a more strong, robust engine. Then what happens is this whole application that you have written is completely wasted, because this whole application that you have written is completely dependent on the underlying hardware, like any embedded architecture. So this is the whole reason why AUTOSAR actually came into place. So the whole objective of AUTOSAR first is, let's say this is the first objective that we are talking about. So whenever we are talking about AUTOSAR, the whole idea of AUTOSAR is to create a layered architecture so that you completely eliminate this top application software component from the underlying hardware. So that is the first and foremost objective of AUTOSAR. Like I can give you another use case, which will be an interior light may look a little simpler use case, but let's assume that Ferrari as a car. Let's assume Ferrari as a car has built a very strong algorithm, and that algorithm actually manages the whole powertrain in such a way that it is able to reach 0 to 240 miles per hour in, like say for example 10 seconds, going a random number. So that's a powerful algorithm that they have written. So after writing this algorithm have been tested. There are so many levels of testing in an automotive, because we are talking about a life and death decision. So there are so many levels of testing. After so many levels of testing, let's assume that over a period of time they have to move on one microcontroller to another controller, or in other words, they have to move from one electronic control to another electronic control unit. This whole algorithm goes to a waste. It goes for a toss. So the whole objective of AUTOSAR, the primary objective of the AUTOSAR, is to separate the application software component from the underlying hardware. That's the first and foremost thing. The second important thing is the BSW standardization. So when we talk about application development in an embedded, what happens is its application software component is the top layer. Usually what happens is after you write the application component, your electronic control unit does not work individually. It requires it is connected to a network. Like you know that any electronic control unit does not work individually. It is connected to a network, and when it is connected to the network, it requires information from the other electronic control units. It uses the underlying stack. When I say underlying stack, it is nothing. It will use a CAN stack. If CAN is the protocol that is used for communication between electronic control units, they will use an underlying CAN stack. Okay. So what happens? The OEM had to pay for two things. OEM, when I say OEM, it's the car manufacturer. So the OEM is the original equipment manufacturer, which is the car manufacturer in our case. So the OEM had to pay for two softwares. One is for the application software component he had to pay, and then for integrating the application software component to the with the underlying hardware, he had to pay another service provider, like say a tier 1 company, like say Bosch or Conti, for that example. So you had to pay for two things. They didn't want to pay for that. They wanted to pay only for the application, because the customer pays for the application. He does not care what BSW or what is inside the technology. He doesn't worry about the technology. He only pays for the application. So the whole idea is over a period of time, they wanted to standardize the stack. Excuse me. So they wanted to customize the application for their requirement and standardize the BSW. So that was the second important reason. And the third important reason was the hardware abstraction. When we talked about the hardware abstraction, it is similar to the first point that we wanted to talk. They wanted to isolate, the OEMs wanted to isolate the application software component completely from the underlying microcontroller. So that it can work independently. So that is one thing, right? So today what happens is in AUTOSAR architecture, the idea is today, if you replace the underlying hardware, today you may have one kind of a board. Tomorrow you replace the underlying hardware, you don't have to worry about the BSW stack, or you don't have to worry about the application layer. The final MCAL alone we will have to modify and put it. So we will talk about what is this MCAL and all those things in a layer. But just to keep you informed, the only thing is it's a layered architecture. So even if you remove the bottom layer, the top layer does not get affected. The top layer is the application software. That's the idea. Reusability of functions. So one of the other challenges that they had is whenever you wanted to add another function into the existing system, like say for example, your car is going to a station, to a service station, right? At the service station, there could be some updates. There are some lot of software updates that are being done in the service station with your diagnostics stack and all those stuff, right? So what happens is, let's say, for example, you want to add another function in the existing legacy methodology. It is very, very difficult because all these things will be, like, say, dependent on the underlying hardware, and there was a lot of challenge. But now what happens is the reusability of function is so easy. You don't have to worry about it. You can add functions, and you can use these functions at different locations. So that's another advantage. And the last is the standardization of exchange formats. Like I said, the electronic control units, we have different electronic control units that are available. And these, a good car, a high-end car was around 100 electronic control units. And all these electronic control units are not managed by a single developer. All these are developed by different tier 1 companies, like I said, Bosch, Conti, etc., etc. What happens is, if they don't standardize this format, then exchange between this data exchange between these electronic control units will be a huge challenge. So AUTOSAR also talks about the whole standardization of the exchange formats inside the ECU. Also, like say, the interfaces have been, like say, standardized. So when I say two software components inside the same ECU, if they have to communicate, how should they communicate? What kind of an interface should be used? All those things are super standardized. So you just have to use those APIs and call the other layer and talk to them. So that's how it is being used, right? So if this is the whole, just a quick note, we can actually let me complete the whole webinar, and then I can take all the questions that we have at the end of the webinar. So we just don't interrupt the flow. So if you have any questions, I request you to post them on the chat box, or you can just make a note of it. At the end of the webinar, we'll try and answer all these questions. If there are any technical details that you want to add, you can also mail us through Altus, and we will be able to reach out to you and answer all those questions as well. All right. So just to give you a quick background about how the existing methodology looks like, this is how your existing methodology looks like. You have a software component. It's tightly coupled with the hardware, and that's it. Right. So here in your AUTOSAR architecture, this is how it looks. You have an application software which is on the top layer. You have an AUTOSAR layer. The AUTOSAR layer is has different layers in turn. Okay, it has different layers in turn, but you have an AUTOSAR layer, and finally at the bottom most below you have the hardware, right? So this AUTOSAR layer actually separates the hardware from the application software component. So application software component is completely independent of the underlying hardware. Okay, I just want to add one important point. Okay. When you think about AUTOSAR as a software component and you're writing your application software component, you can also imagine your application software component is also independent of the protocol. Like say, for example, you're talking about a CAN protocol that you're using for the communication. Your application software component is also independent of the protocol. So that is the level of definition that has gone into the AUTOSAR standard. Okay. So the whole idea is, over a period of time, this AUTOSAR stack and the hardware will be standardized, and we will only work on the customization of our application to suit the passenger or the customer requirements. So the application software component will be modified to customer requirements. These two, the AUTOSAR stack and the hardware, is standardized. We are moving towards it. It's not like it's almost standardized, but we have, like say, some slight modifications, and continuous upgradations are being also done. Right. And just verbal information, all these top points that we are talking about are more, or references are on terms of AUTOSAR 4.3.1 standard. All right. So there are like say a lot of changes that has been brought in the 4.0 standard. So what we are talking about is 4.3.1 standard. All these references are for 4.3.1. Yeah. So now we just talked about why AUTOSAR. Like I mentioned, 5 important points: separating the application components, standardizing the stack, and standardizing of reusability of functions, standardization of interfaces. All those things have been done. And when we talk about what is AUTOSAR, AUTOSAR is nothing but an architecture. Okay, so AUTOSAR is nothing but an architecture. It actually defines how you should write the C code. That's how I should put it. AUTOSAR does not tell you, teach you how to write C code. AUTOSAR actually tells you this is the architecture. This is I mean, it does not teach you. When I say teach you how to write C code, I don't mean that it does not. What I mean is, AUTOSAR does not teach you how to write a function or how to write a macro. All those things which are part of the C programming is standardized. You will write the C program as per AUTOSAR standard. Okay, so you will write the whole C programming as per AUTOSAR standard. That's what AUTOSAR architecture is all about. Okay, so when I'm talking about the AUTOSAR architecture, these are the guys who went on to build this architecture. We have different types of members as part of the architecture. We have the OEMs, which is the car manufacturing companies, guys. The tier 1 companies like say Bosch, Visteon, Veoneer, etc., Valeo for that matter. All these guys are your tier 1 companies, primarily working towards building the BSW stack, or they build the ECUs for your. They also build the complete ECUs, okay, including the application software component for the OEM. So that's the tier 1 companies, and we have the standard software, which I mean by the BSW stack. Okay, and we have the tools companies, like say for example Vector. They provide the tools to generate the BSW stack, to generate the application software component. MATLAB, all these guys are ETAS, all these DSpace, all these guys are your tools guys. And finally, we have the semiconductor company, which is the underlying hardware. We have the consortium of Infineon. All these guys are part. Renesas, and Infineon is here, Renesas is here, Freescale is here. So all these guys are your semiconductor companies which manufacture the board. So when I say even when I say the board, even the ECU or the underlying board, okay, the board is also as per AUTOSAR standard. The tools will be as per AUTOSAR standard. The software will be as per AUTOSAR standard. All right. So all these things will be part of the AUTOSAR standard. So let us say for you as an organization, let's assume that you as an organization, you start a company. Let's say Altus as a company, if they decide, okay, they have an experience in working with, let us say for example, airbag ECUs. Okay, so they can decide. I as a company, I'm going to focus on building airbag ECUs. I'll build the application software called airbag ECUs. And I can sell it to any other company. Like say I can sell it to Volkswagen, I can sell it to Toyota or any other company. I will sell it as per AUTOSAR standard. Toyota can buy the airbag application software from me. He can buy the BSW stack from Vector. Okay, so he can buy the underlying stack. He can buy the board from Renesas. Okay, he can buy the board from Renesas, and he can actually give this stack to, like say for example, Bosch. And tell them, okay, see, this is my application software component. You configure the stack for my application software component and give it. That is something it's possible, right? So my point I'm trying to emphasize is, I as an organization, say for example, Altus as an organization, can focus exclusively on building the application software component for airbag. I can have my strength. Okay, so I can say my airbag will be, if you buy the application software component from me, it will make sure that the airbag is released in, like say, 150 milliseconds. Let's say it will be released in 150 milliseconds. That's the guarantee I can give you, right? So he doesn't even know what is the underlying semiconductor device. He doesn't know what is the underlying BSW stack, but still I can guarantee it, because I assume as per AUTOSAR standard, I built this airbag ECU. So all the underlying software components also will be following AUTOSAR standard. So naturally, my ECU or my ECU will be like, say, my application will be able to deliver that performance. So 150 milliseconds, I should be able to deliver. So that's the whole idea of AUTOSAR. So AUTOSAR stands for Automotive Open Systems Architecture. Like I said, it's not C coding. It actually defines the standard in which you should write the C coding. It's something like your MISRA standard. Like say you write the C coding as per MISRA standard, right? So it is something like that. So where you write the C codes are generated as per AUTOSAR standard. Okay. All right. So in terms of functional domains, AUTOSAR is primarily classified into six functional domains: body comfort, powertrain, chassis, safety, multimedia, and man-machine interface. Okay, so these are the six major domains in which AUTOSAR functionally it is classified into. And what happens in today's market, you will find that even most of these OEMs, when I say some of the best car makers in the world, they have only moved to AUTOSAR standard for body comfort. Okay, only body comfort ECUs to AUTOSAR standard. The powertrain, excuse me, the other domains are not moved. So AUTOSAR will be in the market for the next 10 years. So if you decide to take a career in AUTOSAR, it will be a very strong architecture that will be in the market for at least 10 years, because like I said, we've just moved into body comfort, and there's a whole lot of domains that still needs from migration from legacy methodology to AUTOSAR methodology. And now the European car makers are actually insisting on moving towards AUTOSAR methodologies. Okay. So now that's a quick introduction about why it is we need AUTOSAR, and we have talked about what is AUTOSAR, like what are the forums that are available, what are the members of AUTOSAR, and etc. etc. So now we'll move on to the AUTOSAR architecture. So before I move on to the AUTOSAR architecture, let me just talk about the existing architecture. Give me one moment. So if you look at the existing architecture will look something similar to this. So you'll have a 4-layered architecture. You'll have the application software component, and immediately below the application software component, you'll have a CAN stack, and you will have a CAN driver, and you have a CAN hardware. Okay. Let us say, for example, I as an engineer, or like say Altus as a company decides to develop the interior light control machine using the existing methodology. I think that's a pretty straightforward example that we can take forward. So what is the idea is, as I open the car, the interior light switches. So I'm going to develop this ECU. I'm going to develop this ECU. So in a legacy method, the first thing that Altus will do is he will go and choose the hardware. Okay, so he will go and choose the hardware. Let us say, for example, he uses a particular NXP board. Some series of NXP board he is choosing. Okay, so let's say, for example, for the sake of convenience, let's call it NXP Series 1, just for an understanding. So that's the first thing Altus will go on and decide. Okay, the next step. Okay, now once he decides the NXP board, the second thing that he decides is okay, he needs the driver. Okay, so what do I mean by driver? You need to access all these peripherals, right? So you know, in embedded architecture, drivers. So Altus has to go on and buy the driver from NXP. So he'll say, okay, why don't you give the driver to me, and he will buy the driver from NXP itself. By using the driver, you can use those APIs to send the data to the peripheral, or you can access the peripherals, etc., etc. Right? So we need the drivers, and like I mentioned, the semiconductor provider may provide the NXP. Or in other words, if, like say, for example, if I have a good driver team, if Altus itself has a driver team, they are very good in writing drivers, then they don't have to buy the driver from the semiconductor, because you'll have to pay for the driver also. So I will go on and build the driver. So that is the second option. Then the third thing that you need to buy is the CAN stack. Okay. So that NXP Series 1, there will be some 5 or 6 guys in the market, like say, when I say vendors, who will be supporting NXP Series 1 processors with CAN stack. So what is a CAN stack primarily? The CAN stack is will be able to do all these functionalities. Okay, so it will give you the mode management. It will help you kind of manage the whole objective of going for a microcontroller based ECU is to manage the power, correct? So we need to make sure that the ECU is in sleep mode. There are two series of ECU. One series of ECU which is connected to the ignition. I mean, not connected to the ignition. It is connected to the battery only. All ECUs will be connected to the battery. But these series of ECUs will work only when the ignition is on. And there's a second series of ECUs which will work when the ignition is switched off. Also, like say, for example, your door, even when you open the door when the ignition is off, it will open and it will switch the interior light, right? So these ECUs have to be maintained in sleep mode when there is no power, right? So you'll have to manage the mode. You'll have to manage the data flow. You'll have to manage the diagnostics. You need to do the flash bootloader, all those things. So like say, if you sometimes if your CAN packet is greater than 8 bytes, then you may also have to do a TP, segmentation and reassembly. So all these things will be done by the CAN stack. It will be done by the CAN stack. So you need to buy the stack from some vendor, and then you will buy this application and you will integrate it with the CAN stack and make sure this data goes from top to bottom and the ECU is built. So this is the typical way of building a ECU, okay, in the legacy method. But in your AUTOSAR, it is a completely different method. So I want you, I'm just trying to tell you the whole storyboard of how ECU is built in an AUTOSAR. So let's say, for example, Benz as a OEM decides to build a ECU. The first thing is he will write the application layer. He will write the application component because he will not try to kind of show his IP. It will be his IP. So he will try and build the application software component. He will build by this entire stack. Okay, like say you have a runtime environment, and this is the basic software. This is what we call it as the AUTOSAR layer. Okay, the runtime environment with the BSW. Okay, so this whole guy, he will go ahead and buy it, and then he will buy the microcontroller. Okay, so this is the complete AUTOSAR stack. Okay, this is the complete AUTOSAR stack. And when I say an AUTOSAR stack has primarily two important fellows. It has the basic software. See, this is the basic software. Okay, this is the basic software and the runtime environment. Okay, so these are the two guys which are associated with the AUTOSAR. All right, and then you have the microcontroller. So an AUTOSAR layered architecture primarily has, like say, 3 layers. I will say it has got 3 layers. Let's take this microcontroller out. Okay, so it has got 3 layers. We have an application layer, we have a runtime environment, and we have the underlying BSW stack. When I say the BSW stack or the basic software can be broken into 3 or 4 more layers. Okay, so you have a services layer, you have an ECU abstraction layer, you have a microcontroller abstraction layer, and you have a complex device drivers. All right, so you have 4 layers in the excuse me, you have 4 layers in the BSW stack itself. All right, so this is the whole architecture of AUTOSAR. Okay, now let me go and explain what is the role of each of these layers and tell you, like say, how it works, etc., etc. But again, I want to, like say, emphasize when I'm talking about an AUTOSAR architecture. I just want to go this slide here. Sorry. Okay, this guy. Okay, so this is the guy. Okay, so this is the AUTOSAR intermediate layer that we are trying to insert. So when I'm saying the intermediate layer that I'm trying to insert, this is the application software component. This AUTOSAR layer has got the entire BSW stack and the runtime environment. Okay, so that AUTOSAR layer is nothing but the runtime environment with the BSW stack. BSW stack in turn has got 4 layers. The BSW stack in turn has got 4 layers. Okay. All right. So this is the application layer. This is the runtime environment. Now what I'm breaking up is I'm breaking up the BSW layer. We had 3 layers. Like I said, the violet one was the services layer. here. The violet one was the services layer. This guy was your ECU abstraction layer. This guy is your ECU abstraction layer. And this pink guy is your MCAL layer. This pink guy is your MCAL layer. Here it is. This guy is your MCAL layer. Okay. And finally, you have the complex device driver. You have finally the complex device drivers. All right. So I'm just talking about this guy. There's the services layer. You have a ECU abstraction layer. You have a microcontroller abstraction layer, the complex device driver. This is the complex device driver. This green guy is your ECU abstraction layer. This is your services layer, and this is your microcontroller layer. Okay. Now we will talk about each of these layers in detail, but the whole idea is, like say for example, I have an application layer. I have a very common runtime environment. Both these guys are common to the ECU. Okay. The IO abstraction layer. This guy is primarily used for accessing your IO. Like say for example, you want to control the IO pins. You want to control the PWM. You want to use the ICU or the OCU, etc., etc. Then you use the IO hardware abstraction layer. So this is something. These guys. This line is more focused towards IO. This is the communication stack. Okay, this is the communication stack. See, you have communication services, communication hardware abstraction, and communication drive. All right. So I'll come to the diagnostics stack also will sit here. The diagnostic stack also will sit more or less here. And this is your offboard communication services. This is more focused towards your offboard services. This is what we want to specify here. This is more about your crypto. Okay, let's say for example, you want to enable crypto service to make sure your ECU is secure. This is your crypto stack. Then you have the memory stack, and you have the system services and other onboard device abstraction. When I say onboard device abstraction, let's say for example, your watchdog. Okay, you have your watchdog. This is your microcontroller drivers, all those things. Okay, so based on the input from the watchdog, you can reset the microcontroller and all those stuff. So this is all sitting here. Okay, so I can four layers we have in the BSW, and these 4 layers. When I say a communication stack will have a services layer modules. It will have ECU abstraction layer modules, and it will have also driver level modules. Okay, so I'm just using this as a reference for our future communication, so that I don't have to go here and there. So this is the communication stack that I'm going to talk about in a little deeper way also. So this is the communication stack. Like I said, this is the services layer, entire services layer, ECU abstraction layer, and the MCAL layer. In the communication layer, I have services layer components. These are the modules which sit in the services layer, and these modules are used. These modules are configured to serve the communication stack. Okay. Then you have the abstraction layer. These are the modules where you have the ECU abstraction being carried out. And it's also used for communication. These 3 modules are primarily used for communication. And these are the drivers which are primarily used for communication. These are the drivers which are primarily used for communication. Okay, so this is just the communication stack. Okay, so if I just focus on this layer, it comes like this. So I have an application component, I have an RTE component, and I have a CAN signal. That, let's assume a communication stack is more importantly receiving and transmitting a CAN signal. So this stack, this list of modules, all these modules, okay, these modules are primarily responsible for transmitting and receiving a CAN signal. Okay, I'm sorry. Primarily responsible for transmitting and receiving a CAN signal. Okay, you do not have the work of this is Ethernet frame relay and LIN. You don't need this. You'll need this CAN. You'll need this CAN. Okay, so all these modules, if I have to tell, okay, all these modules are part of the communication stack, and all these modules, maybe most of them, maybe some of them are not configured, but most of them will be configured to ensure that there is a smooth flow of data from the application software component to the CAN bus. Excuse me. Okay, so this is the communication bus, and this you have a list of modules here. You have a list of modules here. List of modules here. These modules, all these modules should be configured so that there is a data flow from the top layer to the microcontroller to the bus. The bus will be situated below the microcontroller. Okay. So this is the communication layer. Got it? Okay. So if there are any questions, like I said, we'll definitely take it at the end of the session. Just took water. Yeah. All right. So, like I said, we have defined this BSW modules. AUTOSAR has defined the BSW modules. These are some of the important tasks of the BSW module. When I say operating system actually sits here. See, here it is. The operating system sits here, the AUTOSAR OS. So it is operating system is part of the BSW stack. Access to the non-volatile memory. So like I said, this is a set of modules that are used to access the non-volatile memory. So that is it is provided by the BSW stack. Communication via CAN, LIN, FlexRay, Ethernet, like I said, and handling the diagnostics. Like I said, this whole set of modules are used for communication, whether it could be CAN or it could be LIN or frame relay. Irrespective of that, there will be a list of modules that will be used to ensure communication. So that's what we called as a communication stack. All right, so this is both these guys, even the diagnostics happen through the communication stack. Then you have an IO port. When I say this is the IO port, this guy is responsible for managing the IO. You can see here it is used to control the PWM, OCU, ICU, etc., etc. Okay, so that's all being done. And then finally, you have the systems services like ECU state management. Okay, so that is also being taken care of. What do we mean by ECU state management? Primarily, the ECU manager. Okay, see, you have a manager here, which is in the services layer. This is the ECM manager that I'm talking about. This manager is responsible for turning on the ECU, turning off the ECU, etc., etc. All those things are taken care of. And finally, you also have the complex device drivers. Say, for example, there is a set of modules that you want to AUTOSAR architecture. Like say you have some special protocols that are being used. Those protocols may not be part of the AUTOSAR architecture. That means maybe it doesn't fall under any of these underlying protocols, like say Ethernet, frame relay, etc., etc. So there you use your complex device drivers. Sometimes you will also use the complex device drivers to access the IO as well. So those are all details, but this is where you will use your complex device drivers. So wherever you want to kind of build a protocol, or you want to use some protocol which is not part of the AUTOSAR standard, or you want to kind of skip all these guys. Let's assume that you want to skip all these guys and you want to kind of directly access the hardware. Okay, you don't want to use any of these guys, just directly want to access the hardware. Of course, when I skip, you can't skip the OS, but the other flows you can skip and you can access the hardware, then you can actually use the. All right. So this is the whole idea of AUTOSAR architecture. All right. So let's talk about these individual layers. Let's say the first layer is the lowest layer, is the microcontroller abstraction layer. Okay. So what is the microcontroller abstraction layer? The microcontroller abstraction layer is actually the set of drivers for the microcontroller. Okay. Let us say, for example, I buy a Regasys board. The Regasys board will be as per AUTOSAR standard. The Regasys board will be as per AUTOSAR standard. The Regasys will give me a microcontroller. So the microcontroller will give me all the, I'm sorry, it will give me the MCAL, okay, the microcontroller abstraction layer. It's popularly called as MCAL, okay. So what does this MCAL have? This MCAL will nothing have the address of the drivers. Let's say, for example, CAN driver, okay. There will be in the CAN driver, you'll have the address of the CAN registers. You'll have the, like say, the hardware transmit handle. Sorry, let's use some ordinary terms. You will have the hardware address of the CAN transmitter register. You will have the hardware address of the CAN receiver register, etc., etc. So all those things will be available in your MCAL. Okay, so the MCAL is actually providing you the address of the registers to whom you want to get the access to. That's what is the MCAL all about. Okay, that's what is MCAL about. So what happens is, now let us say, for example, today you are working on Regasys and tomorrow you decide to move to NXP. All that will be needed is you will have to kind of get the new address. You'll get the new address. Okay. And what you will do is you will map the data to the new address. The data will be available in the ECU abstraction layer. The data, let's say for example, some CAN data, some data that needs to be sent through the CAN. That data will be available in the ECU CAN abstraction layer. Once you provide this MCAL address, which is the address to which you have to map it, then what happens is this ECU abstraction layer will map this data to that particular address. Okay, it's just like sending it to the register. Okay, so you use your APIs, and with that API you send it to the right register. That's as simple as what I'm talking about. Okay, so that's the MCAL layer, which provides you the address of the hardware. Okay, or it gives you the APIs to access the hardware. That's the right word. It gives you the APIs to access the hardware. Okay, then I'm sorry. Yeah. Uh-oh. I think I missed on. Okay. Next, we'll talk about the ECU abstraction layer. Unfortunately, I think that slide has been missed for some unknown reason. I just missed the slide. The next slide is the ECU abstraction layer. Okay. So what is this ECU abstraction layer? The ECU abstraction layer is the guy which makes the ECU independent of the hardware, Okay. Let us say, for example, one of the most important aspects, like I said, I'm going to focus exclusively on the communication stack. Let us say, for example, you are building one application, and in that application, you want to send some data out of the microcontroller to the CAN bus, and it happens to the CAN bus. Okay. So let's say that is the basic idea that I want to do. Now, what happens is this application, when you're writing, I don't even worry whether it is like, say, it is a CAN data or any data. Okay, you don't have to map it to a CAN data. You just kind of send the data to the download layer, which is your RT. Here it will be your RT. Okay, you just send it to the RT, right? The RT will in turn push it to the ECU abstraction layer through the services layer for the communication stack. Say here, I'm just going back. Sorry, I keep switching. Okay, so the RT actually pushes the data to the communication abstraction layer. Okay, this is the ECU abstraction layer. Okay, through the communication services. So it is here you are actually adding the CAN header. Okay, if since I'm talking about a CAN header, you have a triplex is nothing but the bus. Okay, here will be a CAN bus. It will be here you will add the CAN header. Okay, and then what happens is you map that once it actually becomes a CAN packet here. It actually becomes a CAN packet. This MCAL will be like, say, giving you the address of this register. What you do, you just map this CAN packet to this address and send it out of the CAN register. It's as simple as that. So the idea is till this layer, it is protocol independent. Till this layer, it is actually protocol independent. Let us say, for example, I take a memory. Okay, like say I have a memory as an example. Okay, now underlying hardware. Okay, this ECU may not have one memory. It have many memories. Let's assume that it has many memories. Okay, it will have a flash memory. It has an external EEPROM, etc. Let's say it has two memories. All right. So here, I don't care about in the application software component. I don't care about which memory I want to send this data to. That and is like say taken care of here. It will be mapped here. Okay. So this ECU abstraction layer, the whole idea is it makes the guy actually independent of the ECU. Okay. It will actually separate the. MCAL layer. Okay. It will actually separate the MCAL. What is this MCAL? MCAL is specific to one ECU, or it is specific to the underlying hardware. Okay, ECU abstraction layer will work with this MCAL and make sure the upper layers are independent of the hardware. Okay, so that's the idea. Now let us say, for instance, I change this hardware. I will get one new CAN address. I will get one new memory address. All those things. What this fellow will do? He will map this memory to this address. He will map the CAN bus to the new address, and it will be that, and that's the end of it. So this is your ECU abstraction layer, which primarily makes it independent of the ECU. Okay. And then there is the third guy, which is the complex device drivers. Like I mentioned, you want to access the drivers, you want to access the underlying drivers, you use the complex device drivers. And if you want to bypass all these layers and directly access the drivers, that's one reason where you'll use the complex device driver. Or the other place where you'll use your CDD is complex device driver, is also called CDD, is where you want to use some special type of protocol and all those things. You'll use the complex device driver. So this is the complex device driver. Then you have the services layer. The services layer is the highest layer. Okay, this is the services layer. Okay, so this is the highest layer there. Okay, you have a vast number of services being offered. Okay, the services are all, like say, protocol independent. Like I said, memory is again independent of the underlying memory. If I say communication stack, it is independent of the underlying protocol. It is, like say, independent of whether the underlying protocol is CAN or LIN. This packet may be intended for LIN, or it may be intended for CAN, or it may be intended for any other protocol. The service does not worry about it. Okay, it will be, like say, protocol independent, memory independent, CTD independent. It will be completely independent. Okay, it will provide all the basic services for the application. What do you mean by basic services for application? Like say, for example, when you want to check what mode I am now. If the ECU in sleep mode, then I cannot transmit the data. So I will check if the application needs to check what mode it is in. That is being provided by the services layer. Operating system scheduling of you know that C is a sequential operation, right? But in your microcontroller, you will need, like say, parallel threads to be run. So you use scheduling, and you will use an operating system. You use an AUTOSAR operating system. So the AUTOSAR operating system is sitting in the services layer. So that service is being provided. Diagnostic services are being provided. Then lot of other services are also provided, but primarily mode management, PSW, etc., like say memory, communication, diagnostics are some of the basic services that are provided apart from OS. Okay, so this is the services layer, and like I mentioned, it is completely microcontroller independent and ECU hardware independent. Okay, that's the most important aspect of the services layer. Okay. And I've also talked about, okay, these are some of the services that we offer: OS, NVRAM, diagnostic, ECU, and watchdog manager. All those things we have talked about. And finally, we come to the RT layer. Okay, the RT layer is the heart of the the AUTOSAR layer architecture. So the RT actually separates the underlying BSW stack from the application. So anything that comes from the underlying, it could be a signal, it could be an interrupt, or it could be of any format. Anything that comes from this, everything gets terminated at the RTE. Okay. Even like say, for example, let us say, for example, today, like just like I mentioned, I have an application, like say Altus as an organization has decided I will develop only the application software component for airbag ECU. Okay. It does not know the underlying BSW stack also. I can buy the stack from Vector. I can buy it from ETAS. I can buy it from EBITResource. I can buy it from anybody. Okay, so I don't care who I will buy it, but it will be AUTOSAR standard. All right. So it gives RT completely gives me this liberty, so that what happens is even if I buy the stack from any of these players, all the signals, all the messages, all the interfaces, interrupts, everything will get terminated at the RTE. Okay. So the application software component is completely independent. So finally, once you, let's say, for example, Volkswagen decides to buy this ASWC from me, I mean, the airbag ECU application software component from me, he'll buy that. He will buy this BSW stack with the RTE from Vector, and he will give it to, like say, for example, some guy like say Altus or Ansett, and they will kind of integrate it with the BSW stack. So that's how this whole organization works. Okay, so AUTOSAR organization works. So the runtime environment is the heart. It completely separates the underlying BSW stack from the application software component, and runtime RTE is like say completely what do you call? I will call it customized. Okay, you can customize it for your application. Okay, and finally, it's your application software component. Like I said, airbag is a simple application software component that I'm talking about. It need not be one component; it could be multiple application software components, and they work together to perform this functionality. And that's what it is all about. All right. So This is something similar to your layered architecture in the OSI model. You have like say 7 layers, right? And when you move your ECU, I'm sorry, when you move your laptop from your office to your home, you are still being able to work with it because the whole aspect of it is standardized, right? So that's the same idea of AUTOSAR architecture as well. Now you can just compare and contrast it with this existing architecture, the CAN stack, where like say, for example, the application software component will directly work with the CAN stack. Okay. So when I write the application, it is actually protocol dependent. Okay. So when I write the application, I am going to write this application for a CAN stack. Now tomorrow when I decide, okay, CAN is like say, not giving me this functionality, I want to move to Ethernet, you cannot move it. Application is already written as per the CAN stack. So you cannot move, change the protocol. It has to remain with CAN stack. If you want to move to Ethernet, that means you'll have to write the application from scratch. So that's the biggest advantage of AUTOSAR. Like you see here, I'm just going back to the CAN stack again. This is the point where it actually becomes a CAN signal. This is the point it actually becomes a CAN signal. Here, all these things, it is just some data unit. Okay, it's called protocol data unit. Okay, so it's just some data that is coming in some format. It's some data, right? Only here you add the CAN header and what do you call DLC. You just add the CAN header and make it into a CAN ID and DLC and make it into a CAN packet. But if you look at the existing stack, see here, nothing like that. Immediately you add the CAN header. So it is like say protocol dependent. So just comparing and contrasting between these two architectures. All right, so I'll go to the AUTOSAR methodology. I'll write it from a tools perspective. Okay, so I also compare and contrast it with the existing guys. Okay, and what is the career option available? Okay, so there are two directions as an engineer we can take in terms of AUTOSAR. One is you could go on to become an AUTOSAR ASWC architect. I'm sorry, ASWC developer, where you go on to build application software components as per AUTOSAR standard. Okay, so this is one way where you can go. This is one tool chain that you can follow to go through that. Expectations are primarily like say you will have like say good experience in tools like say MATLAB and good experience in C logic writing and things like that. So if you are good in that, if you feel like say I'm very good in C and all those things, logics and all those things, this could be an area that you could choose. The other option is you could choose this downward direction. Like say if you want to choose the downward direction, you could go on to become a BSW stack developer. This focuses more towards OEMs like Benz or Volkswagen. Here you work more towards organizations like say Bosch, Conti, etc., where they configure the BSW stack to suit this application. So that's the second career path that we could choose. And once you're familiar with all these guys, both application software component and the BSW stack, then you primarily go on to become a software architect, where you'll use like say tools like say Prevision to kind of build the entire architecture of the OEM and stuff like that. Okay, so that would be like say after 7 to 8 years of experience in both these areas. So this is something that as a career path we have as an engineer, as an opportunity, not as a which I also wanted to touch upon. But basically, in terms of tools, I want to break the tools that we will be using in AUTOSAR into three parts. One is called as an AUTOSAR authoring tool. Okay, so this AUTOSAR authoring tool, if you are familiar with vector and if you are familiar with this word DBC file, a DBC file is basically the database file that we load into the vector stack and configure the legacy method and things like that. So we have something called as an ARXML file. So this ARXML file is what we will be. I'll take 2 minutes and finish this webinar. So so this is the authoring tool. So you need this input ARXML files that needs to be provided, whether it is application software component or configuring the BSW stack. You need to create this XML file. That will be the first important thing. So that's the AUTOSAR authoring tool. Then if you are going to work on the software component development, then use this ARXML files as input and use tools like say MATLAB or raw C coding to build the application software component. If you're going towards the BSW stack, you'll use this input files, and what you will do is go ahead and configure the BSW stack with the ITAS or Vector or EB Resource, whatever, Tata Alexi stack, whatever stack that you are working on, you will configure that stack for this particular requirement. How do we know for this particular requirement? It will be available in the ARXML file. It will be available in the ARXML file. Okay. So that, what do you mean by it's an XML file? When I say it's an AUTOSAR standard, it's called ARXML file. Okay. That ARXML file will be loaded, and you will configure the BSW stack. You'll configure all these layers, and then you will integrate it with the ASWC and create the build. This is the idea. Okay. So this also from the tools perspective. Yeah, I think that's pretty much from us today. So we talked about three important things, like say why we need AUTOSAR, and second we talked about what is AUTOSAR, and finally we also talked about the third important guy, the architecture. Okay, and I told you what is a layered architecture and compared and contrasted it with the existing architectures. So that's in a nutshell for all of you. Thank you so much. You've been such a patient audience. Any questions? I'll take those questions. I'll be glad to take those questions. Now we'll have a questionnaire session. We're done for the webinar. Yeah. Thank you, Altus, for giving us this opportunity. And it's been a wonderful conversation. Yeah. Okay. Okay. So the slide.
Thanks, Karthik.
Yeah.
Karthik, it's really a very interesting session from Ansit. Really appreciate it. Colleagues and candidates, whoever is having any question, please feel free to ask. Also visit Altus-Tech website, where you will see the list of trainings and webinars that are planned. And please feel free to reach us on the numbers and the email IDs given on the screen. Anytime we will be able to assist you with the training programs.
Sure, I have a few questions. Let me take them one after the other. Okay. The first question is, okay, is ECU and microcontroller hardware used synonymously? If not, then what is the difference that we are talking? Okay, see, when I talk about a microcontroller hardware can be as simple as an STM32 board. Okay, it's a very small board. But the ECU is also microcontroller based hardware. Okay. It will have, like say, protocols, like say it will support protocols like say CAN, Ethernet. Some of the ECUs may support only CAN. So that is the primary difference. The memory will be stronger, it will be faster, and all those things. But in terms of, if you ask me, it is also a microcontroller based architecture. Okay, so that's how ECU is also a microcontroller based architecture. Okay, from Kano Bhishma. Okay. Is this presentation shareable? I mean, it is there. We'll post it on YouTube. You can just watch it. We'll share it. Yeah, company. Yes. Thanks for information. If please provide us document and recording, we'll share that. Yeah, Bhishma, you can share the recording. Okay.
Yes, I will do that.
Yeah, when these 4 will happen, Bhishma will help you coordinate. We'll upload the same in Altus website. Yeah. Okay, what is the skill set required for a BSW stack developer? You need to know how to configure tools. Like say, for example, you need to know how to configure the BSW stack. So first, you need to understand the theory behind what are the modules in BSW stack, and what are the areas in which you want to work. And like say, for example, you want to become a BSW stack developer. You can say I can become a BSW stack developer and I can focus on communication stack. Okay, so that could be one niche area in which you want to focus. You cannot become an expert in all those things. So you can focus on communication stack. You can focus on diagnostic stack. So you have like say maybe 6 or 7 modules communication stack. You should know how these modules have to be configured. And once you know those modules, then you become a BSW stack developer. I think that's to Sudha Naik's, I'm sorry, Sudha Patnaik's question. Yeah, any other questions you want to, like say, can they ask questions, Bhishma? Just curious to find out.
Yes, Karthik, they can unmute themselves.
Yeah, you can unmute, and if you have any questions, please shoot your questions. I'll be glad to answer. Okay, like say, what are the skills one should have? Like say, if you're very good in C and you find that you're good in logic, then you can go on to become an application software component developer with more focus towards the application software component and it as per AUTOSAR standard. But if you want to go on to the BSW stack, then you need to find out which area you want to. You want to work on communication or you want to work on diagnostic. And then these are the two primary areas, okay, in the BSW stack.
Hello.
Yeah.
Sorry, I'm from Germany, so it is good evening over here. And
Yeah.
I'm doing a course on vehicle diagnostics. I'm basically from mechanical engineering background. So, what is my opportunity here? If given that I'm not very well versed in programming.
Okay, so what is the course on vehicle or diagnostics on? What does it cover?
It covers the basics of vehicle dynamics. That is from ECU to CAN bus communication, system
Dynamics or
self-diagnostic systems.
diagnostics?
Diagnostics. It is
Okay,
after sales processes. So workshop technology based.
Okay, so what tools do you use?
We don't use any tools. I'm just doing a master's course over here. So this AUTOSAR is AUTOSAR Cano E, Cano, Vector Cano, and are the softwares I'll be needing to learn. So in that case, I'm not into programming or developing of any ECUs. I'm just from mechanical background who is doing an automotive course over here. So in that case, what is my chances? Or which field I should take if I'm interested in vehicle diagnosis?
Okay. To be very candid to your question, whatever we are talking about is software development. All right.
Yes.
Whatever we are talking about is software development. There are two areas in which you can focus on. One, if you're like say good in C programming, one area, then I will recommend you to take AUTOSAR and like say for example, move towards development. Okay. That is one area that I will recommend. If you're not comfortable in C programming, I will recommend you choose a career in Kenu VNV, verification and validation, which again is a huge opportunity on its own, right? So you can actually choose diagnostics and you can you can do UDS testing and all those things, which by itself is a huge opportunity. Okay. Verification and validation will be a good opportunity and more focused towards Kenu. And Keppel scripting. Okay, there you will learn Keppel scripting. Okay.
Okay. Thank you.
Yeah.
Thank you.
Hello.
Yeah.
Hello. Actually, I am currently doing an internship in Hela,
Okay.
and in Hela Automotive.
Hmm.
And I just wanted to ask for any ideas for my next year project. I'm doing a master's degree, and so what can be very good project domains or problem statements that you can suggest?
Okay, I will put it again. I'm just coming back to what is your strength.
C programming.
Then you can actually go on to build one ASWC level integration in AUTOSAR standard for some body comfort. Like say we can take in the body comfort cluster. You can take why I say body comfort is because more likely in your masters you'll be an individual or you'll be working with very limited people, right?
Individual project.
Okay. So in that case, I will recommend you take body comfort because you have less signals. Maybe you'll have around 30, 40 signals. In powertrain, if I tell you something, you'll have 500,000 signals. It will be difficult. Okay. So you can take some, go on and build on application ASWC, application software component as per AUTOSAR standard and integrate it with the BSW stack and test it. It will give you a bright career opportunity after.
Okay. Thank you.
Yeah.
Hello.
Yeah. Hi.
Yeah. Good evening. Hi. So I actually wanted to ask you, like, for example, there are multiple modules that are present in AUTOSAR, right? So for
Correct.
example, if you're working for a company, then it is expected that you are not going to stick to one particular module throughout, and you would be switching between the modules as and when required. So how would you suggest someone going through the requirements to understand, to quickly grasp the modules and not to spend too much of time reading the specifications?
Okay. Like say, if my question is, I'm just trying to rephrase your question. Like say, for example, you're saying there are so many modules in AUTOSAR. If I have to move from one module to another module, it takes so much of time. How do I, like say, read those things faster? Like say, is what your question? That's the question?
Yes.
Okay.
Yes.
See,
Correct.
like I said, when we talk about AUTOSAR, I will recommend instead of looking at it from a module perspective, we can look at it from a stack perspective. I will say communication stack. You focus on communication stack. Say you want to focus on diagnostic stack. All right. So diagnostic stack will have like say one list of modules in which you will configure, work, go deeper into it, right? So even if you move from one company to another company, you say that my specialization is on diagnostic stack, right? So that way it gives you this depth. Once you know the diagnostic stack, then if you want to move to the communication stack, then you may need some, like say, 1 week of effort. That's all. It's not a very complicated process. You need some 1 week of effort and a little bit of training if needed, and that will help you to migrate. I mean, when I move between, like I say, 1 week is for you. For you to master one stack, it may take a little longer time. But for you to move from one stack to another stack, like I mentioned, 1 week should be. Okay.
Okay. Thank you for the information. And just a suggestion, like I have been attending many of the answered webinars. Just a suggestion, if in the, I mean, usually previously they used to be on every Tuesday, something like that. I don't remember
First
the
Thursday,
date.
first Thursday. Correct.
First Thursday of every month.
Correct.
Would it be possible for you to have a session on anytime soon, whenever you would be planning, on the transformers that we have in the AUTOSAR? I mean, the E2E, some IPXF, and the COMXF.
Correct.
If
I would
possible.
love to. Yes, we'll definitely do that. Can you actually? That's a wonderful request. Bhishma, we should do one on transformers. You can just make a note of it.
Yeah. Yes, Karthik, I'm noting.
I mean, that's a huge opportunity, and it's going to be a future as well. Yeah. Thanks for that. I think it's a very nice request. We'll do that.
Thank you. Thank you very much.
Hello.
Hi, Karthik. Mridanga is here.
Yeah. Hi.
Hi, Karthik. I'm following Ansit's webinars generally, and I just wanted to appreciate all the whatever the efforts you guys putting it. It is very nice, and there is no any single line which I couldn't understand. So thank you so much for such a nice and interesting webinars.
You're most welcome. Thank you so much for following us.
Thank you.
Hi, Karthik. I'm Vamsi.
Hi, Vamsi. Yeah.
Hi. On a broader perspective, I would like to know if AUTOSAR will have some impacts on the upcoming trends like EV platforms.
I see one thing what we would like to talk about is there will be, like say, definitely impacts. The powertrain is not going to vanish in the next 10 years or so. That's what I gave you this number, right? 10 years. Okay, so 10 years is quite a number. So I mean, too big to look after 10 years. I'm not sure what is going to happen after that. So for 10 years, it's definitely going to stay in the market. So you can be very confident about it. Because what happens is today only now the migration has started. Like say the standard has, the standard has started evolving from 2004, but only now people have started adopting it. Okay, maybe in the last 1.5 years to 2 years is when people have started adopting it. So it's actually hot, and it'll stay for the next good 10 years for sure.
Okay, because it's interesting topic also for me because I work as a software integration manager.
Okay.
For Mercedes, and we integrate softwares from with the different architectures.
Mm-hmm.
Some of our vCPUs, vehicle CPUs are based on AUTOSAR, and but whereas the others are based on Thrift interface architectures.
Correct.
But as of now, the latest EQS, which was released, if you are aware, in the last month from Daimler, We are still using AUTOSAR for some of the modules. So that's the reason why I was more curious for the upcoming years. I'm not sure how the trend is moving towards. So thought of getting some insight into that. Okay, thank you so much.
Yeah. Once I've read quite a few research papers also on the future of automotive. Whatever I am sharing is also based on those experience and those research papers. But like say sitting inside the automotive industry, anything can happen. One quick decision, then there could be something new. Adaptive has sprung a new surprise. So all those
Exactly,
things
that
can
is
happen.
what
Yeah.
I came to. I just was browsing and there was something like adaptive AUTOSAR that
Correct.
would be launched for EV.
Correct.
And
Correct.
the
So
current
adaptive
version.
AUTOSAR is where you are replacing the microcontroller with a microprocessor. Okay. I mean, one of the interesting things that, I mean, it was after this news that everybody got excited. If you remember the news, this Tesla, when they had this car crash, right?
Right.
I mean, because of that, this guy, what is that, shock absorber, they didn't have that enough ground clearance. They just asked to kind of park the car at one particular time of the night, and they raised the ground clearance by some right? So after that, everybody got excited. Adaptive AUTOSAR. That was where this whole thing started.
Okay, interesting.
They didn't have to pull the vehicles back to the service station. So that was the biggest thing that they did.
Good, because at our level, we don't work too much on the technology. We just, at a very high level of integrating a lot of modules.
Correct.
So, yeah.
See, what happens is, exactly. So what usually happens is then you go deeper into that level of integration, right? So, but I'm sure it's definitely having a good for the next 10 years. It's staying in the market. That much I'm pretty much sure.
Okay, thanks for the update, Karthik.
Yeah. All right. Thank you so much. I think we'll post this presentation also on Alptus website, and we'll definitely come back with a very interesting, like say, topic, like say, transformer very soon. Thank you so much, all of you, for joining us. Thank you, Alptus, once again. Good evening.
Thanks,
and good night
Karthik.
to all the
Thanks,
people
Karthik,
in
for
India.
the nice presentation, and thanks, participants, for your enthusiastic participation. Look forward to hear from you again. Talk
Thank
to you.
you. Bye.
Bye.